Hey everyone, so this is the second lesson on kinematics, and in this lesson we're going to talk about how there are two different types of measurements that we talk about in physics, and they're classified as either scalars or vectors. So we talked about before about the term distance and displacement, how distance was essentially the measurement of an object regardless of direction, while displacement did care about direction. It did matter whether you went left or right, up or down, whether you went in circles, and where you ended up relative to where you started. Now, these two aren't alone. There are multiple other variables, multiple other measurements that we talk about in physics that can be categorized as either scalars or vectors. Scalars being terms that only really care about value, about size. You mostly have dealt with these most of your life. Like when you talk about someone's height and you say that someone's 6 feet tall, you don't normally add in a direction. Wouldn't it make sense that you're 6 feet tall east? Same thing with age, or like I said, distance before. All these are measurements that you normally give without any direction, any inherent left, right, up, or down. Vectors, on the other hand, are measurements that have both magnitude and direction. So you have to include both a value and what direction it's going. And in particular, with vectors, it usually matters what direction you're moving. You can say that an object is displaced 3 miles to the east, or you might say the house is 3 miles to the east. In addition, you could also talk about how fast an object is going, or how you push an object. These are all examples of vectors. Now, throughout the class, I'm going to go through and tell you which measurements. Every time I introduce a new measurement, I'm going to tell you whether it's a scalar or vector. But down here is a list of pretty much the most common ones. You can copy it down and look at it. Keep this in mind. There are a lot of scalars. In fact, actually, for the most part, the vectors I listed on here are pretty much all of the vectors that are going to be covered in the AP class, with the exception of some of the rotational stuff I didn't put on here. But the scalars is actually not complete. And in fact, anything that's not on the list that we ended up discussing is most likely a scalar. So these are all examples: distance, speed, mass, time, energy. Those are all examples of things that you would not normally give a direction to, while things like displacement, velocity, and acceleration are examples. Now, I have actually mentioned usually in the regions class that one way to kind of tell whether or not an object is scalar or vector, it doesn't work all the time, but one way to tell is that you can look at and see if the word is simple or complex. Scalars tend to be simple terms: distance, speed, mass. These are things that you would normally see in middle school. Vectors, on the other hand, are more complex terms: displacement, velocity, acceleration. These are high school terms. Now, it doesn't always work because sometimes instead of using the word force, they might use the word weight, or instead of using energy, they might say kinetic energy. So it doesn't work every single time, but it can help you if you completely blank on what scalars and vectors are. Now, one thing to notice about this chart is you may realize that there are two things colored. Distance and displacement are colored purple, and speed and velocity are colored blue. Why is that? It's because those are defined as scalar vector pairs, meaning that they basically refer to the same type of measurement, but one being a scalar form and one being a vector form. So distance and displacement both refer to how far an object has traveled, but one's scalar, one's vector. And with speed and velocity, they both represent how fast an object's going, but scalar and vector form. Now, some things about vectors, because the vectors is actually something important to talk about. Now, one thing to keep in mind is that this is math here. So if you get really upset, it is not physics. This is technically a math thing. Math came up with vectors. But vectors have a lot of very unique properties, things that we're going to talk about mainly in the first two units, in the kinematics and the dynamics unit. That's where we really are going to hit the properties a lot. So I said before that scalars and vectors both are magnitude and direction, and this is extremely important. A lot of times what they do to represent vectors is they use arrows. So we can actually do things with vectors. We can do some math with vectors by drawing arrows as representations of them. The length of the arrow would represent its magnitude or its value, and the direction of the arrow represents its direction. So here, if I told you how what the scale was for this diagram, you could figure out what the value is and that it was going to the right. Now, there are some other things to keep in mind about vectors. For example, when you do some math with them, for example, if you have a vector and you multiply it by a positive scalar, so a number that doesn't have a direction but is positive, then what ends up changing is just the magnitude. It gets bigger. Well, in this case, it gets bigger. If it was a fraction, it would get smaller. But what's important is that it changes its size. However, if we do the opposite and we actually multiply it by a negative scalar, not only do we change its magnitude, but we also change the direction. It's going to end up flipping directions. So multiplying by a scalar will either make it continue going in the same direction or flip in the other direction. Now, you may notice that it doesn't start going up or down. There is a way to do that, but we're not going to talk about it right this second. Another thing to keep in mind is this: the fact that multiplying by a positive number or multiplying by a negative number indicates a certain direction. This is something we're going to talk about a little bit more in detail, but it is important to note that certain directions are usually defined as being certain signs. For example, to the right is usually seen as positive, and up is also seen as positive, while to the left and down are seen as negative. Why is that? Because of math, because of the graph. X up and x to the right and y up are both positive, y down and x to the left are both negative. Uh, so this can be used when we start doing math calculations. Keep that in mind. Another thing to keep in mind is how we denote and represent numbers as vectors. First, a lot of times you might see some equations. They'll have this little arrow symbol above the letter. That denotes that that is a vector term and includes a direction. So in this equation, we have P and V being vectors, and M is a scalar. Same thing down here. P and F are vectors, and T is the scalar. So you can tell whether or not an object is a scalar or vector based off of whether it has an arrow. Unfortunately, the reference table doesn't do this for every single term, mainly because there are some equations where you can kind of be loose. Sometimes you could use scalars, doesn't matter. But in the equations where it definitely does matter that that's a vector, they denote it. One thing to note though is that a lot of times when questions ask you for a vector term, a lot of times they'll say that they want the magnitude of the vector. That just means that they want the value. They don't care if you add in a direction. If you add in a direction, that's fine. It's whatever. It's not going to harm you if you get that wrong. But all they really care about is the value. However, it is important to be very careful with the reading of the questions. The AP is very notorious for being tricky. And one way they get you to trick you is by making it seem like they said magnitude when they didn't. They like I said, they'll sometimes just ask for the acceleration or just the velocity without including the word magnitude. And because you're more often to see, or more often likely to see the word magnitude of the acceleration, you might forget to include direction. So just be very careful with the questions. All right, and that's pretty much it with scalars and vectors. We're going to talk a little bit more about vectors and then also talk about some of the other types of vectors in this first unit. If you have any questions, feel free to let me know. Otherwise, good luck and have a great day.